All right, this is section 5.2. We're finally moving on to chapter 5. Do my best to present this material to you. So, chapter 5, get our friends here, the cheaters. Binomial probabilities. I'm going to start out here with focus points, and some of the stuff I'm going to go through, I'm going to cut to the chase because your calculator is going to do a lot of this stuff. But the PowerPoint brings you through each and every step, whether you're using the formula here or he talks about in the video using a table, which in the back of the book, which you're not going to do. So it's going to be the calculator, but we need to go through all the steps to see why we're doing what we're doing, not just presenting, hey, here's the calculator. On a TV game show, you get a try at this wheel, the Wheel of Fortune. It's a roulette wheel, 36 slots, and the contestant wins 50 grand if the ball lands on a gold slot. None of the other slots pay out. So in this problem, the contestant and the game show sponsors are concerned about only two outcomes. Either the ball lands on the gold or the ball does not. This is a typical problem of a binomial experiment that he talks about here. Jacob Bernoulli, who studied this stuff, and the criteria, it's a fixed number of trials. The trials are independent, so two successes, two outcomes, a success or a failure. And we know that P plus Q, the probability of a success plus the probability Q of a failure has to be equal to 1. And by the complement rule, Q equals 1 minus P. But here's the deal. When you're using their formula, yeah, you need to know what Q is, the probability of a failure. But when it comes time to use the calculator, we're not concerned with Q. We're just going to be concerned with P. So let's see how the Wheel of Fortune problem meets the criteria. Yeah, there are 100 contestants, so there are trials, 100 of them. The trials are independent. Each spin of the wheel has no effect on the outcome of the spin of a second or third trial. We're interested in only two outcomes. Either the ball lands on a gold or it doesn't. Landing on a gold is a success. Not landing on a gold is a failure. Remember, success and failure are pretty much arbitrary. If you're looking for, the probability that someone gets the coronavirus, well, I wouldn't consider getting the virus a success. So it's an arbitrary thing. So success doesn't always mean a good thing. All right. Here again, we're saying, does not imply success and failure to outcomes does not imply good or bad. These terms are assigned simply for convenience. All right, once again, we know that Q, the probability of a failure, is 1 minus the probability of a success. We get that 1 minus 1 over 36. Why 1 over 36? Well, there's only one slot that contains is a gold slot. One chance favorable over total. So Q works out to be 35 over 36. We want to know the probability of 3. All right, so I say here that the answer, 3 successes out of 100 trials, with a probability of 1 over 36 is 0.23. The next to the last slide, I actually have a link to a video on Vimeo that shows how to do this. It's really straightforward. Central problem of binomials, find the probability of our successes. Let's say you're taking an exam, you only have 5 seconds to do the last 3 questions, and you decide to mark the answers without even reading them. So, assuming your answers are randomly selected, what's the probability you get 0, 1, or 2, or all 3 correct? This is a binomial experiment. Each question can be thought of as a trial. There's 3 trials. The possible outcomes, S or F. Trials are independent. What happens with how you answer one multiple choice has no effect on how you answer another. What's the probability of a success on any one question? Well, there's 4 answers, A, B, C, D. Only one of them is right, so probability of a success is 0.25. Therefore, the probability you get it wrong is 3 chances out of 4, 0.75. So he lists all the different combinations here. Get them all 3 right. Success, success, success. First 2 you get right. Third one you get wrong. And success, failure, success. You see all 8. All right. So question 1, can have two answers. Question 2 has two results. Question 3 has two. So you see 2 times 2 times 2 is a total of, my sample space consists of 8 different items. All right, so if I was trying to figure out the probability of getting the first 2 right successful and the third one wrong, it'd be P times Q. First one right and the second one right, multiplication, and the third one you get wrong. So it'd be 0.5 times 0.5, and getting the last one wrong, 0.75. If you multiply all that out, you're getting 0.007. Now, why is it 0.5 times 0.5? 0.25 times 0.25. Well, success would be getting it right. 1 chance out of 4, which is 0.25. Getting the second one right, 0.25. And then the last one wrong, 3 chances out of 4, 0.75. So you see, it can be done, but we're not going to do it this way. In fact, even on the next slide here, he lists the sample space, getting all 3 right, the last one getting all 3 wrong, and then getting 2 right. And there's 3 ways of doing this. Getting 2 wrong, there's also 3 ways of doing that. All right, but you really won't have to do it. He's just explaining the different series of outcomes that you can get here. So now we can compute the probability of our successes out of 3 trials for 0, 1, 2, or 3. All right, so what about the probability of getting 1 right? Well, there's 3 different ways of doing that. All right, what you're actually going to do in the formula, it's the combination of 3 things taken one at a time. But notice in each one of these, you've got 2 failures. You got 2 here, second and third, a failure of the first, failure for the third. And here you've got 2 failures, first and second were failures. So 3 ways of doing that. So 3 times, but if I do this, each one of those has 1 success, each one of these, all right, and 2 failures. So they're calculated exactly the same way, all right, 3 times P times Q squared, 0.25 times 0.75 squared, but there's 3 of those, 3 different ways I can get that. Combination of 3 things taken one at a time. So doing the multiplication, 0.422. And once again, he figures out the probability of getting none right, 1 right, 2 right, and getting all 3 of them correct. All right, so here's the deal. I try embedding this video into this PowerPoint. Didn't work out well at all. In fact, I'm still struggling with, sometimes when you watch the videos, you see the TI-84 screen will flash. So I'm trying to get the frames up to 60 to avoid that. So that all being said, is when you actually go through the PowerPoint, not this video, but the PowerPoint that I'm going to upload to Blackboard and Canvas, depending what school you're at, you need to stop or go get to this slide and either click on either this link or here's the actual URL, and that'll explain just how I did that problem. Like I say, I couldn't embed it into this slide. So you need to watch the PowerPoint. In fact, what I'm going to do, if you don't have Microsoft Office, I'm going to put that PowerPoint I've converted to a PDF. So once again, you'll have these links that you can click on. And it'll go to Vimeo, and I have a video of me using the calculator to solve each of these problems. There are a total of 8 different videos. So you won't see it embedded here. You'll see it when you actually open up the PowerPoint or the PDF that accompanies this homework assignment. All right, so, here's the little form. It's called a binomial probability, right? So we're taking n things and we're choosing r at a time. So, getting 1 right out of 3, that's why there are 3 ways of getting 1 success. Times P to the number of successes times a failure to the n minus r. If there are r successes, there are n minus r failures. But once again, he gives you the formula, but we're not going to take time to do this. All right, so here's a problem about people being concerned about internet safety. He gives us our p-value, probability of a success, 59% are concerned. All right, so what's the probability that for a random sample of 10 users, exactly 6 are concerned? All right, so 10 trials, you have your p, and you have your r value. Now, when we use the calculator, The calculator doesn't have it doesn't use the R, it uses X to stand for the number of successes, and I'll talk about that in the video. So there's the information. All right, here again for the calculator, we won't have to get involved in the Q value. But using the formula, combination of 10 things, taking 6 at a time, how many ways can I get 6 right out of 10? All right, times the probability of a success, I need it 6 times. Probability of a failure is 10 minus 6. We get 10 different things, and you have 6 successes, then you get 10 minus 6, or 4 failures. So that's the formula. All right, so it could use your table. We talked about that in the video. 5-2, this is Big Al, and I really don't want to go to a table. All right, so in fact, I don't want to use I don't want to use this formula, but he shows us how to get to the answer. All right, and it's blocked out here, so I can't even see what it is. And once again, I do this in this video. It's on Vimeo. So when you're watching your PowerPoint, please click on this and you'll find it pretty straightforward. All right. Many times we're interested in a range of successes. I'm not interested in just 1 or 2 or 3. We want to know the probability of 4 or fewer. 4 or fewer would be 4, 3, 2, 1, or 0. So I could conceivably take all these 5 answers and add them up, use the formula 5 times. Do I really want to do that? Not really. And he talks about here going to the table, which I definitely don't want to do. But here's how you would do it if you could use your table in the back of the book. All right, 6 successes. And we're looking for the probability of 0.50 and number of successes, 4 successes here, 0.234. We're not going to be using the table at all. All right, so he found the probability of 4 successes on the table. 3 was this answer. Probability of 2 was 0.234 and so forth. Then he added it all together. It will take you forever. So here's a video. You're going to have a little slight rounding error. All right, don't get concerned about it because there'll be no answers that are within 1/1000th of another. But here again, using a table which is limited to the number of decimal places versus using a calculator which has, an infinite amount of places actually. There occasionally will be a 1/1000th of an error. Nothing to get concerned about. All right, what's the probability that at least 4 seeds will germinate? All right, and the probability of success is 0.7. At least 4. Or at least 4 means 4, 5, or 6. There's no direct way of doing this. All right, so we're going to have to use the complement rule. Here, he does it pencil and paper. He finds simply the 3 answers, and then he adds them all up. All right, probably a 5 or 6, adds those 2 answers up. Yeah, I see. We have already figured out the probability of 4. So he takes that, he calculates either with the table or with the formula the probability of 5 and 6, adds all 3 answers up, and he's got the probability of number of successes being greater than or equal to 4.745. You're going to find with the calculators the answer is so much easier. All right, we're going to use the cumulative function. The cumulative function has a particular starting point. It always starts with 0. There's no way of telling the calculator, hey, start at 4, find the answer to that with 5, with 6, and add it up. What we're going to do is find the probability of the complement of 4 or more, which is 0, 1, 2, or 3. I can use binomial cumulative distribution. Find this answer, the probability of 0 or 1 or 2 or 3, subtract that from 1, and then I'll have what I'm looking for, 4, 5, and 6. I can't tell the calculator to start at 4. There's no option. It always starts with 0 successes, and it'll stop after you tell it to stop. There is my X or my R value. It'll add all these 4, and if I tell it to subtract that from 1, it'll give me what I'm looking for. The video will do a good job explaining that. All right, so here it is using the calculator, but here again the video, I'm using the cumulative function here, and you'll see the answer is As you can see, 0.744 with a calculator, pencil and paper 0.745. But we're not going to be doing this. You're going to use a calculator for all your work. Certain college, 33% of the physics majors are not minorities. If 10 students are selected at random, what's the probability that no more than 6? There's a great slide at the very end that talks about different ways to take an English phrase like no more than 6 and to translate that into a mathematical phrase. No more than 6. No more than 6 means, hey, 0, 1, 2, 3, 4, 5, and 6 is good. 7, 8, and 9, and 10 are not good. No more than 6 means from 0 to 6, including 6. All right, so there is the using the calculator, but once again, the video is going to put this all into perspective. There's a link. Actually, these both go to the same spot. You wonder why I put them both on there, but probability of at least 2 girls in 7 births. At least 2 means 2 or more. And once again, I'm not going to find the answer to all of these 6 and then add them all up. I'm going to find the answer to 0 or 1 girl being born in 7 births, subtract that from 1, and then I'll have what I'm looking for. That's the fastest way around it. All right, there's a screenshot of the calculator, but the video is a lot better. Not a lot better, but it'll just take you through the steps and I walk you through. All right, so you've got a insurance company where 8% of the drivers were involved in an accident. Among 14 drivers on one particular street, 3 were involved in an accident last year. If 14 drivers are selected, what's the probability of getting a 3 or more that were involved? Well, 3 or more implies 3, 4, 5, 6, all the way to 14. It'd be crazy to find each one of these edges individually and add them up. What we're going to do is use the cumulative, find probability of 0, 1, or 2. The calculator is going to add all those 3 for me. I'm going to subtract that answer from 1, and then I'll have what I'm looking for. 3, 4, 5, 6, 7, all the way up to 14. And there's the video that's going to explain everything. And here's the one where the very first question where the quiz show is interested in, hey, what's the probability they'll have to pay out the grand prize to 3 out of 100 people? And the video shows you, but it's so simplistic after you've seen the cumulative or anything else. This one looks like a piece of cake. So, and here's that slide I was telling you about. 4 or more, at least 4, no fewer, no less than, all right? And there's the inequality. 4 or fewer, at most 4, no more than 4. The numbers of successes does not exceed 4. So it'd be, number of successes less than or equal to 4, which means 0, 1, 2, 3, and 4. I would actually have this slide when you take the exam, which won't be for a while, but have this slide handy because it translates these common phrases, these common expressions into inequality, so you know what you're looking for. Popping the numbers in the calculator is no big deal. We're just going to pop in the right numbers. And that does it for this. Hopefully this came through rather clear. Once again, you've got your discussion board. You've got the email to ask me any questions. It's trying times, and there's no doubt. So we're all working very hard to make this thing happen. So will it be perfect? No, but we'll do the best. I'll do the best I can to get this material out to you.